It directly relates to what I'm going to talk about. I borrowed this title of the talk. People's first reaction is, where's the T? T stands for trust. So I think we already concluded, Christian, thanks to Christian, illustrated why there is no trust in MCP and A2A protocols. Not only, I'm going to also talk about the difference between security and trust. We need both. And so let's get into that. If this works. It's a movie. All right, so very quick introduction of myself. I work for a project that leads on AI and human trust. And you may heard about the open wallet in today's keynote, and also a working group for AI and human trust in LF decentralized trust. So we've been working on a protocol called Trust Spanning Protocol, TSP for short. And so this talk is about how to build AI agents that we can trust to the level that we can actually deploy in real world and have some real functions. Okay, so just to properly set, instead of thinking about how, as a developer, how we can very quickly prototype something, test, and see wonderful things happen, we're going to think about how we actually develop and deploy products to real world, right? So I'm going to share with you two pieces of news. These both happened last week. So in this piece is from Visa. So Visa just announced last week in San Francisco how they've developed a Visa payment protocol so that you can have your agent have your credit card. And so the agent can, for example, buy things for you. So you can say, I'm going next week to Paris. Can you book a hotel for me? And my usual preference, for example, locations such and such, etc. Right? And the agent will do all the rest for you, and you may review it, and the agent then going to use your credit card to go book everything. So now we're thinking this agent is much more powerful and real and potentially dangerous for our use. So the second one is even more interesting to me, and this is from Anthropic, and this is also the same company proposed MCP. In this case, we're talking about a still hypothetical, but a AI agent as a virtual employee to a company. And maybe the AI agent will have the role of processing, your email or security or IT questions or reports and taking actions. So this will be as if one of your admin in your workplace. And so you can imagine what kind of security or accountability or responsibility we should think about on this agent. And so keep those two examples in your head as we think what is the context we're talking about, right? So I'm going to start with, some of you may know Bruce Schneier is one of the pioneers in computer and networking security. And he had a talk also last week in San Francisco about AI trust, security and trust. And really we want to separate the two concepts very carefully. Security, in a very simple sense, says something has not been hacked by a third party. And the key word is the third party we're dealing with. If you and I, are trying to do a transaction, we're trying to protect ourselves from other people. We think of them as potentially bad people there. Okay. Now, trust is actually about the primary parties between you and me. We are friends, but when we are counting money, we will be very careful, make sure the numbers are right. and the proper things are done, and a record is kept, etc. So that is a alignment in value. The two parties are not always aligned, and most of the time they are not. And so the alignment of value talks about how what you want to do and what the agent may do. And that disagreement is what we talk about when we think about the trust. So I'm trying to introduce these two words that a lot of people use them as if they are the same. I hope we can recognize they are not the same. It's a very different problem to solve. And I would basically make a statement to say that security alone is not enough for agents. And how do we do that? Oh, don't move. Don't move yet. Okay. So I'm going to start with an example of as far away as from AI as possible. I'm talking about Roman empires and the emperors in Roman Empire. The emperors want to protect themselves with security. The way they do that is they hire these Praetorian guards, and they are elite guards to protect themselves, right? So when we evaluate these guards, we are the emperors intuitively know that you need at least two things. One is competence. They're actually elite, they're actually good. And the second thing is they're loyal to you, so you can trust them. The two are very different things. And sure enough, the Romans don't. Okay. Next, please. No, previous one. So the Romans didn't do this job very well, okay? And so this is a painting of this event where the Roman emperor was murdered by the gods, and so this is actually the aftermath. They picked Claudius as the new emperor, and because the emperor wanted to, for example, remove the power and the kind of impact these gods have over, as they accumulate the power over a long period of time. But this is introduce a conflict as we would think about it as a value misalignment, which then these trust issues really become very serious and sometimes fatal. So I hope this example gives you a sense of these issues, and then we're going to come back to this statement about security alone is not enough for autonomous agents. And I think we want to also think about the issue of autonomous. When we talk about agents, they are always somewhat autonomous. So we sometimes simply skip the word autonomous, but they are making decisions, right? These are decision-making entities, which are not exactly what you specified. By definition, what you said to the agent is different from what the agent may understand or may interpret or may decide to do. And so the autonomy fundamentally thinks you have to think about yourself and the agent are two separate entities. So these are not passive software that a particular programmer decided to put in, so you have a clear chain where that happens. The decision-making process is fundamentally a separate process from what you want to do. Okay, so let's, not yet. So let's look at the almost all of our web services and most of the applications and what Christian talked about earlier using APIs. There's a client server, and the best well-known software to do that is OpenAPI. And these are basically the type of security protocols that you could implement using that. So when we speak of security, we are really thinking about implementing one of these. They give us basically probably the best practice of today's status quo. okay? And we want to see that's not enough. So this picture basically shows a common way of this thing could happen. Next. So this is useless, right? Can I get rid of it? Next. You're going too quick. One at a time. This is. Yeah. So the issue with Open API or any kind of existing security infrastructure is that the trust issue is either sidestepped or presumed, or they are hidden. They are not exposed. And so if I expose that particular picture, the rest of the so-called system, they'll have this yellow circle and red circle about actually control of the system. So these are the controllers which give you a certificate, give you an ID, assign you, roles, and then do maybe role-based access control, stuff like that. And so that's a system that's behind the scenes that we typically don't see. And so the very immediate question would be like, do you actually can always trust your system admin, for example? And we have numerous problems in the sense of like where that actually goes, right? So if you empower something without any limit, the downside or the risk there is also unlimited. So most of the organizations segment them and give them certain rights to certain people, but they're trying to limit them so that there's a balance. Okay? Now, when we talk about the agent, if you treat them as a software, this piece of software has no checking. Next, please. And so let's say if we put the agent code in any of these circles, each one of them can become an agent with an ALM embedded in there to make decisions, for example, or remotely, being able to connect to a ALM to make decisions. And so these circles all of a sudden become a autonomous entity. And we need a system so that we can control them or manage them the same way we would manage, for instance, an employee or a contractor, or for example, when we go buy a house, you use a real estate agent. If you go trying to, let's say, go to a bank, you have another agent. So these agents will have some responsibility that you delegate to them. And you will have to have a way to sort of negotiate or monitor that their actions are actually supporting your interest. And that's not automatic. And we need a protocol, a scheme, or some system to do that. Right. Okay, next. Okay, so that's what we were talking about, some basic primitives of trust in addition to security to support this. Next. Okay, so we already talked about MCP. This is good. This gives us a way to sort of connect different features. But what we are doing is we are enabling this ALM-based brain with hands that can actually do things, which means there are consequences, right? And so before we go do that, we should be clear what we can actually do. Yeah. Next, please. So this is Elena Cross's original blog post about S in MCP stands for security, and I think I don't have to explain anymore. She goes into a lot of good examples of explaining where the problems are. Okay, next, please. And there you go. There's tons of things, but I think we don't need to get too much into that. Christian talked quite a bit about as well. So next, please. Now, what I want to say is that even we implemented all these things, basically our best practice we have today is that's still just security. It doesn't handle trust. Next, please. I just want to show this picture because this talks about A2A, the agent-to-agent protocol. This is the one way to think about how this may be connected, but the role they play are similar. And so agent-to-agent protocol does specify, for example, how you use open API and how do you do authorization or authentication, all of that. Okay, next. And this is another way to sort of link, think about from your application in this blue box and how you are dealing with different pieces, right? Next. And there you go, they talk about authentication and authorization. Okay, next. But it's still just security. Next. All right. So I'm going to do the second part of the talk to basically say, well, let's say we have these agents, we properly implement our security. We need that, right? Good. What else we need to do in order to have trust or the kind of thing we are talking about, the new primitives for these agents? And so I'm going to start with a very quick summary of this trust spanning protocol. And I think at the end of it, I hope you understand what the new world model we are talking about. It's a new kind of language and new primitives, right? So I'm going to start with wallets. Okay, so it's think of it as an object that you create. And so the wallets, in a mobile phone, we actually have digital wallets there. But an abstraction of that, it will be some kind of a very secure, long-term, reliable storage of some kind, let's say, that you can put your keys and secret in there, right? So we'll start with that as a wallet, and the wallet need to be embedded somehow in the client, servers, agents, all the things we built. So that's number one. Next. Number two is we will then put stuff into the wallets. Most of the thing in our physical wallet, we have two categories of them. One of them is identifying or unique identifiers to us as a person or some kind of a property. I'm an employee of this company, citizen of this country, stuff like that. The other one is money, which is also a token, but the token is not identified uniquely to me, unless you put it into account, where the account then it becomes a different kind of identifier. So if you think these two categories, it gives you some kind of identity where you can then use it for authorization and authentication. And the key thing here is that this identity need to be long-term. Long in relation to where the agent can be autonomous. Some of the agents are autonomous for a long time, then this identity will be long-term as well. So they need to be somewhat persistent. Like human identities are persistent. We are born with a name and you don't usually change them, or for at least not every day. Otherwise the name will be kind of meaningless, right? So that's the quality of this identifier need to be. And so there's a lot of technical issues to solve. How do you provide proper identities like that? But let's imagine we have these, and these you can keep it in the wallet. Next. With those two things, then this particular protocol, TSP, provides a directional authenticating messages. So now you can have signed messages from party A to party B. And when you do that, we use this asymmetric encryption and signing algorithms. And the one thing I want to say is the shared secret is no secret. If I whisper something to you, a secret, well, it's no longer a secret. At least two people know them now, right? And you have no control over the other party to disclose it. So it's not a secret once you share it. But all of our encryption algorithm today, every single one of them, use share secret. So they are fundamentally not very secret. And that's okay if the two parties are fully trusted with each other. That you are buddy to buddy, everything I know, you know too, that's great. But if you don't trust that way, well, you cannot use share secret. And so this is very important that we have a asymmetric relationship between the two parties that allows you to state precisely that the A told something to B instead of B told something to A. In the end, the both parties get the same information, but that direction we intuitively know in life is very different, right? I hope you see that point. So this is very, very different. Okay, and so that allows us to have these, I would call authenticity and privacy or responsibility. So authenticity about accountability. So when something bad happens, you can sort of, think about liability, for example. Right, if something went wrong, is the agent's problem or is I told them not very clearly enough? So that's very important to distinguish. And privacy and all that is talking about responsibility. So if the system or you're providing a product that requires certain things, you want that to be certain. And that's clear and can be proven to a third party without doubt. Next. Okay. So with all of those, then, so we think of TSP as a layer in, similar to, the internet protocol. You can then build many trust tests or applications on top. And so those are the, we call trust tests. And examples I have, credential exchange. So I'm presenting a identity card to you, and you look at it, verify it's me. And so those are credential exchanges. Delegation is another one that's very relevant to the agent, because if I give the agent a task to do, I'm delegating to the agent. So agent need to be able to act as if it is me to some limitation. So the delegation is a very delicate kind of a thing to do. It's not easy, and I would say normal security protocols don't talk about it. So delegation is a very important one so that we allow or empower the agent to do things on our behalf, but with limits. Next. Okay, so I hope I explained to you the main concepts behind TSP and some of the primitives that it supports. And the next thing is that MCP and A2A, or any kind of like agent, to agent or other kind of a protocol, can run on top of a TSP and automatically gets all the features and support the TSP enables. So I hope to be able to show some of the way how it's done, but next please, I think next slide. Yeah, so next slide we go into a little bit of a code example of how this could be done. And I'm trying to show how, relatively, I think, straightforward how this can be done. So this is a common code example for MCP. This is directly from MCP GitHub. And then alternative, the yellow highlighted one will be showing a TMCP. It's basically exactly the same MCP protocol if you're looking in higher layer. Your JSON objects, everything looks the same. But underneath the transport level, we are using TSP. Okay. And so that allowed me to basically say, when I create MCP, I say TMCP, and you give a name. Now that name needs to be unique. So you provide a name. You'll probably need some kind of a namespace so that we don't reuse them. So that gives this particular agent or server or whatever you're building a unique identity. And so if you look at behind the scene, right, it will be a cryptographic identifier that really linked to a public-private key pair that is then embedded or stored in your wallet. And the very important thing here is that key pair not only exists, but you can rotate them. So the keys can be changed so that the identifier stays the same. So it's a persistent long-term identifier with a key pair and can be rotated. Okay, so beyond that, your server code looks the same. Now, because we're doing this, you will need the client side also do the same thing. The client will need get an identity card in the wallet, and then when they talk, there will be a validation on both ends on who you are, and because the messages are all asymmetric, so you will be able to tell like who told somebody what, yeah, in that order. And the order is how you have accountability, because otherwise it's a shared secret, we will never know who leaked the secret. And now we can know, right? Okay. So, so that's one piece of code I will show just, sort of as an example. Next, please. And we'll show one more piece. This is related to A2A. So A2A has a quite interesting, and you will see, I like this example because you can see it's writing the server code here, and uses a very interesting thing called agent card. They actually call it a card. So that is the ID card you want to have, right? So the ID card will say a lot of things. Will say, who produced this agent? What software it runs? Who issued it? So there's a lot of things in there. So that gives you basically a generic description of this agent itself. You will need a very unique number in addition to the agent card, because you need a serial number for the agent, for the instance of agent that you are using, because that agent has a memory directly associated with you. So these will all go into the wallet. And you can also see that here you have a Google API key. A lot of people just cut and paste your key to your code. I wouldn't do that. I wouldn't definitely submit that code to GitHub. So you want these keys to be in the wallet as well. And how do you do that? Is you associate those keys as data structure to the ID you have. Yeah? So you identify, essentially link all this secret information, and it's stored as an object in the wallet, right? So the only thing else we need to do is basically take the server code as it's implemented today, and then we add a T to it by essentially initialize a wallet, initialize some cars, IDs, and then call a TSP. So that's what basically how the implementation will work. It looks very similar. Okay, next. All right, so I'm going to do a very quick recap. Hopefully I get the key points clear. When we say my phone has not been hacked, that's security. When we say I'm okay to let Alice do shopping for me, that's trust. I'm giving my credit card to Alice and say, can you go buy some this week's grocery for me? That's a lot of trust on her. I'm giving that power to her. Today's APIs, they support security. You can do quite good security, but they don't do trust. And so tasks such as checking credentials, delegating responsibilities, auditing is another thing. And also reputation, right? So if reputation is built along the line of some kind of a permanent identity. Yeah, my reputation is really tied to my face, my name, and all those things, right? And so if this person changes every day, there's no reputation to speak of. Luckily, the humans don't change every day that quickly. So the last thing I want to say is that if you are thinking about MCP or A2A or are using it today, consider giving your agents a T. S is not enough. You need a T. And I would very much love to talk to you about TSP and how to properly implement the T, MCP, T, A2A, whatever your choice of a protocol you want to use. Yes, I think I have one more. Yeah, so I'll provide some information on the TSP's specification and a SDK. Both of them are in draft today, so it's a work in progress. I welcome your interest. Maybe join this work. We have some code segments today. I was trying to do some demo, but I think I won't have the time. So, but otherwise, I would love to talk to you all about how to really do this and make sure that the agents we built, right, we are giving them, everybody is so excited to give them these servers. Remember, each thing you give to them, you give them more power. So before you go too far, make sure we have a good understanding and good control of the agent. Thank you very much.